Elizabeth Son, and I'm a third-year student majoring in animal science at Cal Poly San Luis Obispo. Today, I'll be presenting my research titled Effects of Dietary Sodium Alginates on Growth Performance and Renal Gene Expressions in Broiler Chickens. First, I would like to introduce myself and share a bit of my backgrounds. I was born and raised in South Korea, and I'm not the first in my family to go to college, but I'm the first one to study animal science, and I'm really proud of that because it's a field that completely new to my family, and it's allowed me to find something I'm truly passionate about. Through my time at Cal Poly at this project, I had the opportunity to work closely with Dr. Kang, who is the field advisor of this project in our animal science department at Cal Poly. And working with him and being part of this research helped me see new career directions within animal science, especially in animal research and public service. So next, I'll talk a little bit about my backgrounds of this research. At Cal Poly, this USDA research project has been running for 3 years, and each year focusing on a different feed additive for a broiler chicken. In the first year, 2023, the team studied spirulina and nanocrepsis. The results from that project were presented at the PSA conference and California State University Biochem conference and the PIPA conference as well. In the second year, 2024, the research focused on carrot pomace supplementation using a byproduct from a juice production as a natural fiber source in poultry diets. The results from that study were also presented at the PIPA conferences. And this year, which is 2025, our project focused on sodium arginate supplementation, examining its effects on growth performance and renal gene expressions in broiler. So our study continued this series of projects that examine natural and sustainable feed ingredients for poultry productions. Now, I would like to share why this topic is important. Poultry has become the most consumed meat in the world since 2019. This is mainly because it's affordable, nutritious, and widely accepted across culture. Compared to red meat, poultry is lower in fat and cholesterols, making it healthier and cheaper protein option for consumers around the world. Another reason for poultry demand is increasing is because it has fewer cultural and religious restrictions than the other meats. For example, some countries avoid pork or beef, but poultry is generally accepted almost everywhere, which is why global poultry productions keep rising every year. To meet this demand, the poultry industry has made incredible progress in genetic selections, nutrition, and management practices. Over the last 50 years, modern broilers have become almost twice as heavy as before due to selective breeding and improved feed efficiency. While this growth is impressive, it also comes with challenges, particularly related to animal health and stress. As a broiler grows faster, their metabolism becomes much more active, producing more reactive oxygen and nitrogen compounds in the body. This causes 3 main types of stress. The first is oxidative stress, which damages the cells. The second is inflammatory stress caused by tissue irritations. And the third is hypoxic stress, which happens when the body doesn't get enough oxygen. These stresses can weaken the immune system and reduce overall performance, so minimizing those stress factors has become a major focus in poultry nutrition research. One potential solution to reduce stress is sodium arginate, a natural polysaccharide extracted from seaweed. Previous studies have shown that sodium arginate can improve immune functions and has antibacterial properties in animals. However, there is still limited research on how it affects broiler growth and renal genes expressions, which leads to a focus of this study. The main object of this research was to evaluate the effects of sodium arginates on broiler chicken in 2 different ways. The first was growth performance, which is body weight, feed intakes, and feed conversion ratio. The second was renal gene expressions, focus on stress-related genes for oxidative, inflammatory, and hypoxic stress. For our experiment design, we used 270 of 1-day-old chicks divided into 3 treatment groups with 6 pens per treatment and 15 birds per pen. The first group the control group did not receive any sodium arginate. The second group received 0.05% sodium arginate in their diets, and the third group received 0.1% sodium arginate. All birds were fed a corn soybean-based diet at libitum for 6 weeks. Body weights and feed intakes were recorded weekly, and kidney samples were collected at the end of gene expression analysis. Here we can see body weights and body weight gain across 6 weeks. All 3 groups follows the similar trends, and there were no significant difference among treatments. This means sodium arginate didn't harm or improve growth, and it simply showed that it is a safe additive to use in broiler diets. This graph shows feed intakes and feed conversion ratio. Overall, there were no major differences, but at week 6, the 0.1% group had a slightly lower feeding intakes and a better FCR. This might mean sodium arginate helped improve feeding efficiency, even if the difference wasn't statistically significant. In this figure, you can see the expression of 6 stress related to renal gene. Overall, control group showed higher activation of stress-related genes, while the 0.1% sodium arginate group shows lower expression for several of them. In particular, genes related to oxidative and inflammatory stress were downregulated, which suggests that sodium arginate helped stabilize the bird's physiological condition. So even though growth performed didn't change much, the molecular data indicates that arginate-fed birds were under less internal stress. For our conclusion, to summarize, growth and feed performance didn't change significantly, but sodium arginate-fed birds had lower stress gene expressions, meaning more stability. So sodium arginate can be considered a safe, natural additive that may help reduce physiological stress. Beyond the scientific finding, this project also had a big impact on me personally. By started working on this research, I realized that I wanted to pursue my master's degree in animal science and continue into USDA field rather than going for vet school. Through my first research experience, I also learned how to communicate and collab with others, and I came to understand that people can view animal science from very different perspectives, which really helped me appreciate the field in a different way or in a new ways. This slide shows some photos from the summer industry tour in Arkansas, where our student visited facility and conference. I unfortunately couldn't attend due to family emergency, but I'm planning to participate in the next summer. And these photos are from the winter industry tour, which takes place across Northern and Central California around the Bay Area. It's a study tour of commercial meat business where students visit livestock harvest and carcass fabrication facilities, further meat processing and retail operations. We also learn about processing procedure, regulatory standards, and current issues in the meat industry. I'll be joining this tour next month in December, and I'm really excited to see the process from farm to retail firsthand. Before I finish, I'd like to thank everyone here in this meeting for listening to my presentation. I'm truly grateful for all the people who supported me and helped me to get to this point, especially my advisor, Dr. Kang, and the USDA Research Extension Experience for undergrad program for giving me the opportunity. Thank you.